Before we plunge into the declaration, it's vital to comprehend what molecular accelerators are. The Large Hadron Collider, LHC, operated by CERN, is a 17-mile ring of superconducting magnets and the world's biggest and most powerful particle accelerator. It represents the zenith of human scientific achievement. In fact, it's so powerful that it can reproduce the very conditions present at the birth of the universe. But could this machine, designed to unlock the secrets of the universe, hold the key to something far more ominous? CERN, established in 1954, is one of the world's most prestigious research organizations, with 23 member states and thousands of scientists. It is a hub for collaboration and innovation. The LHC is CERN's flagship project, but it's just one part of a vast network of accelerators and experiments. Imagine a circuit, not for cars or horses, but for subatomic particles in a race against space itself. The LHC accelerates protons to nearly the speed of light, sending them on a collision course that replicates the energy of the universe at the moment of the Big Bang. These collisions create temperatures over 1 million times hotter than the core of the sun. Thousands of magnets guide the protons on their journey, while intricate cooling systems keep the magnets at temperatures colder than space. The beams inside the LHC collide at 4 points around the accelerator ring, corresponding to the positions of 4 particle detectors: Atlas, CMS, ALICE, and LHCb. Each serves a unique purpose, investigating different aspects of particle physics. Together, they act as colossal cameras, capturing snapshots of these collisions. Scientists then sift through the debris, searching for signs of the elusive Higgs boson, also known as the God particle, and other phenomena that offer clues to the universe's fundamental building blocks. By studying the microcosm, we gain insights into the cosmos. Yet, with each answer comes another question, and with each discovery, a new challenge. The LHC is not just a scientific instrument. It is a testament to human curiosity and innovation. It embodies our relentless pursuit of knowledge and our desire to understand the fundamental forces that shape our universe. But as we push the boundaries of what we know, we must also consider the ethical and existential questions that arise. What are the risks of probing the unknown? Could our quest for understanding accidentally unleash forces we cannot control? In the sacred halls of CERN, where the limits of human understanding are constantly pushed, a revelation has emerged that sends a shiver down the spine of even the most seasoned scientists. Brian Cox, a former researcher at CERN and a respected voice in the world of particle physics, recently made a declaration that has left the world both fascinated and fearful. Cox's words resonate with haunting clarity. The goal of CERN's Large Hadron Collider is to recreate a mini Big Bang. Yes, you heard that right, a smaller version of the very event that birthed our universe. The physicist further explained the implications of this goal, highlighting the LHC's extraordinary potential for making new discoveries. This includes its capacity to unlock the mysteries of the Higgs boson and explore dark matter, a mysterious substance that constitutes a significant portion of the universe. Imagine harnessing the power of creation, the ability to evoke the very essence of the universe. It's an enticing possibility, but one fraught with danger. The mini Big Bang is not a theoretical concept. It is a tangible reality within the LHC. The temperatures, pressures, and raw energy all mimic the conditions of the universe's origin. It's like standing at the very dawn of existence, witnessing the birth of creation itself. Yet, with such power comes responsibility. The question looms, what if something goes wrong? In fact, something did go wrong back in 1978. Russian physicist Anatoly Bugorsky experienced a catastrophe that would forever change his life. While working on the U-70 synchrotron at the Institute for High-Energy Physics in Protvino, Russia, a malfunction led to his head accidentally entering the direct path of a proton beam. The beam, with an intensity that defies comprehension, passed through his skull, entering the back of his head and exiting through his nose. Bugorsky's experience was surreal. He saw a flash brighter than 1,000 suns but felt no pain. The beam's path left a trail of destruction, burning through tissue and bone. Yet, he remained conscious and even walked to the clinic for treatment. The aftermath was both horrifying and fascinating. Localized tissue death led to the loss of hearing in one ear and partial facial paralysis. Remarkably, his intellectual faculties remained intact, and he continued his scientific career. This incident is not just a personal tragedy, but a cautionary tale that underscores the immense power and potential danger of particle accelerators. The risks of a collider like the LHC are not to be taken lightly. The potential for unforeseen reactions and the manipulation of the very fabric of space-time are not the stuff of science fiction, but real concerns voiced by some in the scientific community. One of the most disturbing and captivating concerns about the LHC's experiments is the possibility of creating a miniature black hole. Black holes are regions of space-time where gravity is so strong that not even light can escape. They are cosmic vacuum cleaners, devourers of stars, enigmatic entities lurking in the shadows of our universe. The idea that the LHC could create such an entity, even on a microscopic scale, is astonishing. Could such a black hole grow uncontrollably, devouring Earth from within? Scientists at CERN assure us that any black hole created would be unstable and would dissipate instantly. Yet, the mere possibility has ignited debates, fears, and a sense of wonder about the power we wield. It's essential to understand how the LHC could create a black hole. When protons collide at nearly the speed of light, the energy released is so immense that it warps the fabric of space-time itself. Imagine a stretched trampoline with a heavy object dropped onto it, creating a deep depression. This is a simplistic analogy for what could happen in the LHC. In the world of quantum physics, where the rules of the universe are both bizarre and beautiful, there exists a theory that extra dimensions may be hidden within our reality. If these dimensions exist, the LHC's collisions could tap into them, creating a gravitational funnel that forms a tiny black hole. This mysterious dance of particles has even drawn the attention of renowned scientists, particularly the late Stephen Hawking. In his work, he warned of a scenario where the Higgs boson could become unstable at extremely high energy levels, potentially leading to a catastrophic vacuum decay, a cosmic event that could annihilate not just Earth, but the entire universe. The esteemed British cosmologist and astrophysicist Sir Martin Rees also voiced his concerns about experiments at CERN. In his book Our Final Century, he explored the potential risks associated with particle collider experiments, including those at the LHC. His words were not merely cautionary, but carried a tone of existential dread. He discussed a worst-case scenario where a catastrophic experiment could trigger a condition called vacuum instability. In theory, this instability could set off a phase transition that would ripple through the very fabric of space-time, resulting in a cosmic catastrophe engulfing the entire universe. Rees's concerns weren't limited to theoretical musings. He assigned a probability, albeit low, to these apocalyptic outcomes. However, he argued that even a minuscule chance of such a devastating event should give us pause. The stakes are unimaginably high, and the margin for error is razor-thin. Scientists at CERN have conducted exhaustive risk assessments, run simulations, and scrutinized theoretical frameworks to ensure the LHC's safety. Brian Cox himself acknowledged the significance of responsible experimentation, recognizing the widespread fears and concerns surrounding the LHC's activities. He emphasized that rigorous safety measures, extensive reviews, and protocols are in place to ensure the LHC's operations are conducted with the utmost care. Cox reassured the public that the energies involved in the LHC's experiments are well within what the Earth naturally encounters, and the likelihood of creating a stable black hole is astronomically low. Even if a black hole were formed, scientists assert it would be so tiny and unstable that it would evaporate instantly through a phenomenon known as Hawking radiation, a concept proposed by Stephen Hawking. It would be a fleeting moment of cosmic wonder, a brief glimpse into the unknown, and then it would be gone. Nevertheless, the notion of opening a doorway to another universe or dimension has captured the public imagination. This idea, while largely dismissed by mainstream science, has fueled speculation, fear, and even myths. Could the LHC accidentally unleash forces or entities beyond our comprehension? Some have sensationalized this concept, portraying it as opening a portal to hell in various media, further stoking uncertainty. But how did this notion arise, and what does it truly mean in the context of scientific exploration? The concept of parallel dimensions isn't new in physics. String theory, a leading contender for a unified theory of everything, posits that there may be more than the familiar three dimensions of space and one of time. These extra dimensions could be compactified or hidden within our reality. If they exist, the LHC's high-energy collisions might reveal them. The idea is both thrilling and daunting. What if we glimpse a reality beyond our own, or, more ominously, release something we can't control? Such ideas might seem like science fiction, but they underscore the profound responsibility that comes with pushing the frontiers of human knowledge. The LHC's experiments are designed to answer some of the most fundamental questions about our universe. What is dark matter? What happened in the first moments after the Big Bang? Are there hidden dimensions or forces yet to be discovered? Each experiment brings us closer to unraveling these mysteries, but it also reminds us of the ethical considerations that accompany such groundbreaking research. The LHC is more than just a machine. It's a symbol of humanity's quest to understand the cosmos. It embodies our drive to explore, innovate, and push the limits of what's possible. Yet, as we venture into the unknown, we must tread carefully, aware of the potential risks and the profound questions we confront. The future of particle physics holds both promise and peril, and the journey is far from over. In the end, the LHC represents a delicate balance between curiosity and caution, a reminder that, in our quest for knowledge, we must remain vigilant, responsible, and ever aware of the cosmic forces we seek to understand.